So this project probably is a little overwhelming to start. And so what I want to do is in this video is just give you a quick run through of what files I'm giving you and give you a little help with the logic to get started. So the student files, this is the directory with everything that you need. And so I'm going to open it up, and the text files is all of the files with random text in it, and we'll look at that in a little bit. And this is a template to get you started finding secret messages. But anyway, to download this, just click on here and go to download, and it'll make it a zip file, and then you can download everything. All right, I've already done this, so this is going to take a while, and I'm just going to close that out and cancel it. And so I've got all of the files right here. And I've got my text files, and I've got my message finder template. And so let's look at the text files first. This is what we have, right? And there are 18,000 files that look mostly like this, all right? Some of them have secret messages hidden in them. When you're viewing these files also, right, it's a little bit weird to have to scroll sideways to view these, but if you go to the word wrap, it's a little bit easier to scroll through and see what's inside. All right, so the next question is, how do we find messages in these files? Well, let's just think about one file. So that file I just opened up a second ago, that file 000.txt. I am going to open it up and show you what we can find out about it. So I'm going to comment out a couple things here. So I've got this function read file that opens up any a file at any path, reads it, and it returns the contents. And this is just going to be all of the characters in a file is just one big string. And so here is the line where I make the function call to open it. Text is going to be the contents of the file, and I'm going to run it, and we print it out, and there we go. So it is 18,000 characters of random text. So that's not real useful to see. But one of the things that we can do is count the characters in the file. So I have this function get character distribution up here, and I have the code folded so you can't see it, but the code is there. I just have it hidden right now because I want you to write that one on your own. But if I run this program, it returns a list of numbers that looks like this. And so the printable characters are characters 32 through 126. So in this list right here, this is the number of times that ASCII character 32 appeared, which is the space character, by the way. This is the number of times the exclamation or ASCII 33 appeared. This is the number of times ASCII 34 appeared, 35, and so on. And then the very last number in the list, this is element 94, and that's the number of times it appeared. And so there's 95 items in the list. And in fact, on a standard American keyboard, there are 95 characters you can type. That means going through all the buttons, once without holding shift and once holding shift, you're going to get 95 typable characters. All right. So that's the number of times each thing occurred. And, when you look at the counts, right, if the distribution is truly random, I hope it makes sense that we would expect to see roughly the same number of each character in the document. And it seems like all of these numbers are fluctuating, around the same area. In fact, I could go to, if there are 18,000 characters, and so we got 18,000 characters, and there are 95 containers to put them in. I'll divide by 95. I would expect, on average, 189.47 characters in each spot. Obviously, I can't have decimal characters for real, but when I look at this distribution, it looks like that's basically what's happening here. All right. So now that we have this list of numbers, the next thing we can do is compute a chi-square value for the set of numbers, right? And we know the expected value. I just showed you that. And when I compute the chi-square value, right, another function I have, this is expecting to take a list of numbers, and it returns the chi-square value, and I'm storing it in X, and let's print it out and see what I get. Okay, and it turns out that the chi-square value for this set of numbers related to the character distribution of this file is about 80.77. So what does this number mean? Well, on its own, not much. All right, but what we can do with the chi-square value, it's supposed to measure how far away from what we expect, right, 189s, is this distribution. So, a chi-square value of 80 on its own doesn't mean anything, but here's what we can determine. If I were to read some other file here that had a distribution that was, more out of whack from random, like maybe, it had some characters that appeared in it 300 times or something, and it had some characters that appeared in it only 50 times or something like that, what would end up happening is we'd get a higher chi-square value. So, the higher the chi-square value is for a distribution, the more away from what you expected it to be it is. It's more out of whack. And in the case of inspecting these random text files, right, if the distribution doesn't appear random, that's pretty good evidence that maybe there was some information in there because something was placed in the file, right? Something is deliberate happening in the file. So, all right, so let's think about what we're trying to do with our text files, right? That process of open the file, count the characters, and compute the chi-square needs to happen for every single file in this list. Now, there are 18,000 of those, so I don't think manually changing this 18,000 times, looking at the chi-square and looking at the chi-square values is something I want to do. So instead, I have another template that we can use. And I am going to go down to the very bottom and uncomment out the main algorithm first, just so you can see it. And so what I have here is, I've got this num files, which is 18,000, because that's how many files are in that folder. And let's skip the threshold for now, and let's go down to this loop. So this loop for n in range num files, right, this is going to count from 0 to 18,000. And remember, it is not inclusive of the last number. So n is going to take on all the values from 0 to 17,999. All right, so we're just going to count. And that's good because that's how the files are numbered. Now, one little problem with that is you'll notice my files are not numbered in decimal, and the range function counts in decimal, but my files are all numbered in hexadecimal. So we'll have to address that problem. Just another FYI, it looks like some files are missing here because he's like, hey, there's file 000, where's 0001, where's 0002, and 0001 is there, 002 is in the folder. They are all there. It's just that because these are hexadecimal, Windows is not, it's not sorting them correctly. It's sorting them alphabetically, not, and it doesn't understand how to sort hexadecimal numbers. If there were decimal numbers, Windows would be able to figure it out. All right. So anyway, we've got this. So n is a number, and so we want to read file 0, but the way we read file 0 is we need this file name. So I have this function up here, at least a stub for you, that is supposed to take a numeric value and return it to a file name that looks like this. It's the number with some leading zeros. And so what you need to do is just take this pass statement out, and write code that takes that number and returns a string that looks like that. I'll go back and talk about a strategy for doing that in a minute. Okay, so anyway, let's assume this works. We get the file name associated with that number. The next thing we need to do is get the content of that file. And so the get file content function, which is already written, will open up that file and it's going to return the contents as a string, right? So now we have the text that's in the file, right? The get char counts function is going to take that text and go up here, and it's going to return the counts in a list. And this is a description of how that list should be structured, right? And then we have the counts. And then we're going to compute the chi-square function. We're going to compute the chi value for chi-square, and I'm storing it in x here, right? And now let's think about this threshold. Okay, so if I were to do this, right, what I could do, what's going to happen is it's going to loop through all of the files, right? Get the file name, open it up, get the counts, compute the chi-square, and then it's going to print the file name with the chi-square next to it. And what I'm going to have is a list of 18,000 file names and associated chi-squares. That's a lot to look at, because what I'm really interested in is just the files with the big chi-square values. And so what I'm going to do instead is pick a threshold, and I only want to print the file names of those that have high chi-square value for their character distribution. And so, this number 50 is wrong. It's too low. I'll say that. So when you run it, you're going to see lots and lots of file names getting printed. It's going to be overwhelming. But what you can do, after you look at what the chi-square values tend to be, you can probably start taking some educated guesses and hone in on a threshold that is more appropriate and more limiting. So I think eventually you should be able to come up with a chi-square value that maybe is high enough that only 20 or so file names get printed out. All right. So anyway, that's the overall logic. So I'm going to comment this out again. And let's talk about how we can get started. So I've got your three functions here, and I want you to be able to work on one at a time without worrying about this whole program working, all at once. And so the get file name function, right? It's supposed to take a number and turn it into a name. So I might start something like this. I'll say like fname is equal to, how about file underscore, and then I'll say plus n, and then I'll return f name. And so this is my initial guess. I know it's not going to work, but I think it's going to do maybe it might do approximately the right thing, and then I can revise it. So once you start working on a function, what you can do is come down here and uncomment the region associated with testing that function. So I'm going to go uncomment region, and then I can run it. And so I get an error, right? And this is normal. And oops, it says n is not defined. Oh yeah, it's should have been num. Okay, let's run it again. And now it says can only concatenate str, not int to str. And it's like, oh yeah, I've got a plus operator here. And Python doesn't understand if I put a string on one side and a number on the other. So what I can do is change that number to a string before I concatenate. And now, okay, so I'm kind of, doing the right thing. But when we look at this, right, what I did here is I wrote the output that should have happened. So, right away I notice it's like, oh, I forgot the txt at the end, right? So I'll copy that. And maybe I can go plus txt at the end. And let's run it. We'll get a little bit closer. Okay. So I have another problem here, which is, the actual file names are numbered in hexadecimal, and I am still dealing with the decimal numbers. So what I'm going to do, at this point is I'm going to get onto the Google, and I'm going to Google Python, and I'll say decimal to hex. Yeah, and I think you should be able to click through some of these links and figure out a way to take this number and turn it into a hexadecimal number. So that's one problem that you can solve. Another problem that you'll need to solve is, the small numbers, right? This is a single digit number, A is 10, has to be padded with leading zeros because in every case I used 4-digit hexadecimal numbers. So you will need to write, some kind of conditional that checks the length of the hexadecimal number and figures out how many leading zeros you need to append to it, right? So that's what you can do. Then you can move on to the get char counts function. Now, you already basically did this in another assignment, so you have some code you can copy and paste in here, but you're going to need to modify it to return the list in the format described here. Once you get that done, just go ahead here and uncomment the region and run it, and you should get the output you see here. And if you don't get the expected output, then go back and work on your function, right? Once you get that's working, go do your chi-square function. The chi-square function, you have a quiz earlier where you wrote about chi-square function and looked at some code, so I think that should help you get the chi-square function working here. All right, go ahead and uncomment that and test and make sure you get the 6.8 and the 13 for the two chi-square values. And if you don't, it's not working correctly yet, all right? So once you have all of these functions working, get file name, get char counts, and chi-square, right? When you know they work because they produce the expected output, we can go ahead and comment out this region again. And then I'm going to go down here and uncomment this region and run it. And this should work. So you'll have to experiment a little bit to get an appropriate threshold. But once you get a threshold that's spitting out about 20 files or so, printing out about 20 files or so, right? Then you'll have a list of files to go visually inspect, right? Just go open up the file in Notepad, scroll through it, and see if you find any messages, all right, in there. If you are on, a decent computer, it shouldn't take more than a couple minutes to open, read, count the characters, and compute the chi-square for all 18,000 files. On my computer, I think it takes about 30 seconds. One piece of advice is this will be much faster if you work locally. So if you were saving your files on Google Drive, this could end up taking quite a bit more time because you have, you're reading files over a network. Whereas if you save them somewhere locally on your computer, it will be much faster. All right. And once you see this, I think you will find several messages really quickly. Read those messages, and they will give you hints for decoding some of the other sneakier messages, the ones that are encrypted. And if you have any questions about this, let me know. Otherwise, if in the next couple days, what I'm going to do is get some extra videos up, giving you some tutorials on writing programs to decrypt encoded messages. All right, I will talk to you later in another video.